My name is Steve Webb from Webb Yates Engineers, and this is the new Stone Age exhibition at the Building Centre. We started working with Pierre Bidaud about 15 years ago, designing stone staircases, or traditional stone staircases for people's houses. We worked a lot with stone after that. We developed with Pierre different techniques for post-tensioning and reinforcing stone and really pushing the way that stone is used structurally forward. We've been working with Amin for about the same period of time, and when Amin's project at Clerkenwell Close started, we found an opportunity to introduce structural stone, and Amin, Pierre and I all worked together on that project. And we've been really interested in developing stone design and developing technologies in stone and really rediscovering the use of stone structurally for architecture going forward. In this exhibition we have a 12-metre floor span, 450mm deep, post-tension stone, completely viable way of making a 12-metre span floor in an office. The carbon footprint of that section of floor is something like a tenth of the equivalent in steel or concrete. So it's very, very low carbon. It's also beautiful to look at.
I'm Pierre Bidaud. I'm a stonemason and I'm working at the Stonemasonry Company in Stamford. The Stonemasonry Company is a small business, a small stonemasonry business, specializing in load-bearing masonry, as well as post-tension and reinforced stone structure. We have been in the last 10 years developing a partnership with Steve Webb, engineer, and Amin Taha, architect, trying to push forward the use of stone not as only a decorative material, but as a load-bearing material as it used to be a long time ago.
My name is Amin Taha and I work in a practice called Groupwork. We're standing on top of 15 Clerkenwell Close, which is featured in the exhibition at the Building Centre because it's made of limestone and load-bearing limestone in the form of an exoskeleton. While we were working on a stone staircase, which is follow the same principles as all medieval and Georgian staircases, which is part cantilevered, part reciprocal, we were talking to the stonemasons on that project about the prospect of building in load-bearing stone. Surely there's a method of doing it which doesn't involve cutting blocks into slithers, post-tensioning them with a stainless steel rod. And these French stonemasons looked at us in disbelief that we didn't know that load-bearing stone in France is called austerity construction because it's cheaper than concrete or steel. And of course it's the simplest method of construction.
So 15 Clerkenwell Close was a close collaboration between engineer, architect and craftsman. Amin Taha just decided to go a step further in the use of stone, not having only as cladding but as having it true to what it is made for, which is a load-bearing structure, a solid stone structure. So based on the past project we've done with Steve Webb and Steve's knowledge of stone and how it behaves, we decided to reintroduce stone as pillars, as lintel, and see if it could carry the whole building.
While we were actually investigating on the type of stone, we visited a quarry, and the quarry master said, well, no architects ever come and visit us. In fact, no stonemason ever comes and visits us. We just get asked to supply the stone, and we cut it absolutely cleanly in blocks. Those are subdivided, and then the stonemason tends to add their decoration. And the reason I mention this is because as we were wandering around the quarry, fascinated by the various quartz pockets and ammonite shells in the stone and various other fossils, we were asking the quarry master, well, this looks quite natural to us, while most stonemasons will tell us natural is actually a carved-in finish that's achieved with chisels and blowtorches. Instead of us inventing a sort of visual vocabulary addressing for the stone, why don't we allow the intrinsic qualities of the stone itself and the skills of the quarry masters to be that dressing? On making that decision, it does mean that variation in finish would make placing an absolutely regular window within that frame quite difficult. So if you then separate the two, the envelope and the exoskeleton, what you quickly realize is that the envelope can then be a fairly inexpensive curtain wall without any of the sticks. It's just glazing end to end, held up at every floor. Pretty much uniform, perfectly sealed, so it's waterproofed and weathered without the worry of waterproofing on every opening, and you don't have to tool any of your stone either.
You have to start using low energy materials. Timber is one of those, and people are advocating for the use of timber quite widely, but there are things that you won't always use timber for. Nobody's going to make a nuclear power station out of CLT, for example. You know, there are opportunities to use other materials. So stone, because stone is very, very high strength, maybe 2.5 times stronger than the average concrete. Those materials exist in the ground. They're there to be dug up. They're there to be used in a relatively unprocessed form. And actually, with modern analysis and design, post-tensioning stone, using stone in cleverer ways, better statistical analysis of stone's properties, we can unleash the potential to use stone for, well, not only infrastructure, but other big buildings, applications where you can't use timber, and actually as a replacement for big components of buildings.